Hello everyone. So in this video we are going to discuss a very common problem related to binary search, and the problem's name is first occurrence of any number in a sorted array. Okay, so this is our problem statement. The problem definition or name: first occurrence of a number in a sorted array. So let's discuss our input. So our input will be a array which will be in sorted form. Suppose we have array 1, 2, 2, 2, 3, and then 10, then 15. Suppose this is our array. Then we will be given a number. Let's name it as target, and we have 2. Okay. Then the output, what we have to return here, is the index of the first occurrence of this number 2 or this target in this array. Okay, so let's find out what will be the output. This is index 0, 1, 2, 3, 4, 5, and 6. Okay, and the first occurrence of 2 is this, the index 1, so output will be 1. Okay, I hope you have already watched my video of binary search algorithm, but I will be discussing it one more time here because we will be using binary search to solve this problem. Okay, so what we do in a binary search, we have basically 3 pointers or variables. First is start, then end, and one is mid. Okay, initially we will initialize start with 0 and end with array dot size minus 1. Okay, whatever our array will be given, we will initialize the end with the end index of that array. Okay, that is array dot size minus 1 if we are using vector anything. So what we are doing in binary search, we are calculating this mid using the start and end, and the equation which we use to solve this to find this mid is equal to start plus end minus start divided by 2, and I have already discussed why we use this formula instead of using start plus end by 2. But let me tell you one more time, because suppose we are using declaring start and mid as integer values. Okay, and we are having any value. Suppose we are having end as integer max. Okay, and we know that integer data type cannot store any value which is greater than integer max. Okay, and we have having any start value, suppose 1. So if we add integer max plus 1 and try to divide it by 2 or try to calculate this value, we can't do that. Okay, it will give an error. So to resolve this error, we use this equation. It will calculate, both will give the same value, but this will not give any error. So this is correct and this is not correct. Okay, so what we did in binary search, let's apply binary search to this array, and we have to find this value too. Okay, so let's start. We will be applying binary search on this array. So let me write down the array one more time for you: 1, 2, 2, 2, 3, 10, and 15. Okay, and the number which we have to search is 2. Okay, and as I said that we need to initialize start and end, then we need to calculate mid. Okay, so the initial value of the start is 0, and end is 6. Why? Because this is 0th index, this is 1, 2, 3, 4, 5 and 6. Okay, we initialize the end with the last index of that array. Okay, and what will be the end? End is start 0 plus end minus start divided by 2. So mid will be 3. Okay, mid is 3. So this is our first value which we are going to check, that if mid is equal to target, then we will return true, otherwise we will return false. And we found that yes, we got 2. Okay, then we will return true. So this was the quickest, I think, dry run. So let's think that how we can use binary search to solve this problem. Okay, suppose what we can do, let's write the binary search algorithm first. We will calculate mid as a start plus end minus start divided by 2. Okay, then we usually check if our ARR of mid is same as target. We have three conditions: or ARR of mid is greater than target, or else, means ARR of mid is less than target. Either it will be equal or greater than or less than. Okay, no fourth condition is available. So this is binary search. Okay, binary search. What we were doing here, if our target value matches the mid value of the array, the current mid value of the array range, then we simply return true. Or else what we are doing, if our target is smaller than the mid value, that means we have to restrict our search in the first half of the array, means here. Okay, then we will simply perform and is equal to mid minus 1, or else we have to restrict our search in the last half, means first the second half, means we have to do start is equal to mid plus 1, and then again this will calculate mid according to the new start and mid end value, and we will again perform this until we reach we reach any result, until we found this target or start becomes greater than end. Okay, then we will pause, then we will pause. So what we can change in this code, what changes we can perform in this code to get the solution for this question. What was the question? First occurrence of a number in an sorted array, and we will be given an array and a target value. What we have to do, first of all, we have to find whether it is present or not, and then we have to return the first occurrence, means index of its first occurrence in that array. Okay, cool. So suppose this there can be two situations. Okay, this target is present in the array and target is not present in the array. Okay, these are the two conditions which are possible. So if it is present, then we have to return some index. What if it is not present? Okay, if it is not present, then we have to simply return minus 1. Okay, we have to simply return minus 1. So what we can do is yeah, okay, we can check that we can calculate the mid like we do in binary search. What if we got some mid value and we found that our mid value is equal to the number we are looking for, but we have to return the first occurrence of it. Okay, so what we can do, we can perform end is equal to mid minus 1, and along with that we can store the current answer or the current index mid value in it. Okay, we can store the mid value in a variable answer. So let me write fresh algorithm for you, so it will be easy for you to like go through or make a dry run. So first of all, we need to run a loop till our start is less than or equal to end. Then we have to calculate mid using start plus end minus start divided by 2. Then we will match if our mid value is same as the target value, then we will store the result and we will restrict our search in the first half. Okay, because we have to find the first occurrence. Okay, and is equal to mid minus 1, because we know that we have already found one value which is same as target, but we need to check whether we have any more values in the array which is same as target and is stored in the first half. Okay, if there are no such values, then we will return this answer. Then we will perform the second condition, else if ARR of mid is greater than target. Okay, it means we have to restrict our search in the first half. Then when we perform end is equal to mid minus 1, and the final condition, it means we have to restrict our search in the second half. So we'll do start is equal to mid plus 1. Okay, and at last we will return answer. And I forgot to tell, the initial value of answer will be minus 1, because if we don't find any values which are equal to target, then we will simply return minus 1. Okay, so the time complexity of this solution is order of log n, and the space complexity is order of 1, because we are not using any extra space. So let me give you a dry run of the solution. Okay, so our array was 1, 2, 2, 2, 3, 10 and 15. Okay, let me separate it, otherwise it will be confusing for you. This is index 0, 1, 2, 3, 4, 5 and 6. Now we have four variables: start, mid, end and answer. Okay, and the initial values of these variables are, for start we have 0, for end we have 6, answer we have minus 1, and we need not to initialize this, but it is not mandatory. Okay, then we will have to calculate mid. Let me write I have already written the formula. Here is that formula: mid is equal to start plus end minus start divided by 2. Okay, so let us calculate mentally. 0 plus 6 divided by 2 means 3. Index is 3. So our target value is 2. Let's check the condition. Okay, our value of ARR of mid is ARR of 3 is 2, and our target is 2, so it matches. Okay, so what we will do, we will simply copy the value of mid in answer, and it will be 3. Then we will perform end is equal to mid minus 1. We will restrict our search in the first half, okay, of this array. So end index will be 2. Again it will check whether start is less than or equal to 2. So we can see clearly see our start holds 0 and end holds 2. It is, this condition is true. Okay, then we will again calculate mid. What will be our mid? 0 plus 2 divided by 2 means 1. Okay, then we will find this value. We can see that we will again check that our ARR of mid, that is 2, is same as the target value, which is 2. Then what we will do, we will simply store the value of mid in answer, and it will become 1, and we will restrict the search in the again first half of the array of this range, okay, which is 0 to 2. So we will perform end is equal to mid minus 1. So what was our mid? Our mid was 1 and our end is 2. So we'll perform mid minus 1 means 0. Then what we will do, again we will calculate this mid because we have checked the condition and we found that start is less than or equal to, it holds the equality condition, okay. So we will calculate the mid and our mid will be 0, okay. And we found that what is the value stored at ARR of 0, that is 1. Is it equal to target? No. So we can check our the value is 1 and the target value is 2. Is our target smaller than ARR of 0? No, it is greater. What we will do, start is equal to mid plus 1. Okay, we will increment this start by 1. Why 1? Because our mid holds 0. Okay, then we will again check the condition and we found that new value of a start is 1 and end is 0, and we found that this condition no longer is true, okay. Our start is greater than end. So what we will do, we will exit from this loop and we will return our answer. And what is our answer? Our answer is 1. And what is the value stored at 1? We can clearly see that it is the first occurrence of our target variable value, okay. So this was the solution of first occurrence of any number in a sorted array, and we have the technique which we have used is binary search, okay. If you don't know binary search algorithm, then do check out my binary search algorithm video. I will put the link in the description. And if you enjoyed this video and you learned to calculate the first occurrence, then let me give you one homework. Try to find the last occurrence of a number in a sorted array. You have to make a few changes in this code and you can easily find the last occurrence of a number in a sorted array. So thank you. Have a nice day.